Hi everyone, in this video we're going to be looking at the discriminant and we're going to learn how to determine the number and type of solutions of a quadratic equation using the discriminant. So just a review of what complex numbers are. A complex number is a combination of a real number and an imaginary number. So complex numbers include every real number, because for real numbers, the imaginary part is just equal to 0. So in the complex number system, we have real numbers, which is what you're primarily used to working with, and we also have imaginary numbers. So the quadratic formula is also going to be used in this lesson, and just as a reminder, I have it here. And we need the quadratic formula to give us solutions when we can't find them on the graphing calculator or by factoring. The graph may show up on the graphing calculator, but remember, if they're imaginary solutions, they're not going to cross the x-axis, and we're not going to be able to use the calculator to find the zeros, since they'll be either above or below the x-axis. And then lastly, we have the discriminant here. In case you don't remember, the discriminant is the part of the quadratic equation that is under the radical. So the part that is under the radical. Using the discriminant, quadratic equations can have real or complex solutions, and you can determine the type and number of solutions by finding the discriminant. Now, I do have a short video on my channel called Understanding the Discriminant. The link is here. Recommend that you watch that. That also will help you understand how to use the discriminant to help us with determining solutions. All right, now, if we just examine the discriminant for a quadratic equation, if the value is simply positive, all we need to know that it's positive, we know that we're going to get two real solutions. If the value of the discriminant is 0, we know we're going to have one solution. And if we get a negative discriminant, we're going to have no real solutions, but we'll have two imaginary solutions. Now, here's a really good visual of understanding why that's the case and what the graphs look like. So if we have a discriminant that is negative, so the value is going to be less than 0, that means that we're going to end up with an imaginary number under the radical. So that means that we're going to have imaginary roots, imaginary solutions, and we're going to have no real solutions. And our graph is not going to cross the x-axis. If we have a value of discriminant equal to 0, we're going to have one real root, or you could sort of think of it as a bounce. So we have two roots, but they're the same value. So in that case, the discriminant is equal to 0, and we just touch the x-axis in one place. And then the last possibility here is where the discriminant is greater than 0. And if it's greater than 0, we're going to have two real roots, which means we're going to cross the x-axis twice. And it doesn't necessarily have to be pointing in a U shape. We could have an upside down U, but we would still be crossing the x-axis in two places. Right, so that's pretty much it for understanding the discriminant. It's meant to be helpful, so let's look at some examples. So for each one of these, we're going to find the discriminant, and then we're going to determine the number and type of solutions. So we're going to do b squared minus 4ac. And what do we get when we do that? And just as a quick review, keep in mind that the value in front of the quadratic term is a, the value in front of the linear term is b, and the constant is c. So for this particular problem, b squared minus 4ac, we're going to have 8 squared minus 4 times a times c. And that'll give us 64 minus 64, which is equal to 0. So when the discriminant is equal to 0, that means that we have one real solution. That's going to be this example, one real root. So we'll put 0, 1 real solution. Okay, same thing for number 2, b squared minus 4ac. Right, this time we got a negative number, which means that in the quadratic equation, when we use the quadratic formula, we're going to get a negative under the radical. We get a negative under the radical, we know we have 2 imaginary solutions. Okay, let's try number 3. Again, b squared minus 4ac. When we do b squared minus 4ac, we get a value of 9. That's a positive number. Since 9 is positive, that means we will have 2 real solutions. All right, so for the rest of these, I would suggest you pause the video and then come back and check your work. Okay, so that's it for those practice problems. Let's move on to the next page. For each of these problems, we're going to find the discriminant, we're going to determine how many and what kind of solutions are expected, and then we're going to use the quadratic formula to find the solutions. Okay, so let's do number 11. First, let's find the discriminant. All right, so we get a value of 0 when we find the discriminant. That means that we have one real solution that we're expecting when we use the quadratic formula. Okay, so let's use the quadratic formula. It's going to be negative b, in this case negative 20, plus or minus the square root of the discriminant. We already know the discriminant is 0, over 2a. So we're going to get negative 20. The square root of 0 is just 0, plus or minus 0, over 8. So we get a value of negative 5 halves as our solution. So we did get one real solution. Okay, let's try number 12. First, we're going to find the discriminant. When we do that, we get a value of negative 116. That means we're expecting two imaginary solutions. All right, let's use our quadratic formula. Negative b plus or minus the square root of the discriminant over 2 times a. So that's 2 plus or minus. Now I'm going to break apart this negative 116. I need a perfect square factor to simplify this. So negative 116, if I, fiddle around a little, I'll discover that negative 4 times 29 is equal to 116. And now I can simplify that negative 4 under the radical. So let's keep going here. So we get 2 plus or minus. Now, the square root of negative 4 is 2i, and that leaves root 29 remaining under the radical. So let me just highlight that. So this square root of negative 4 becomes 2i, and that still leaves the square root of 29 under the radical. And then, of course, we still have 12 in the denominator. Now at this point, if we divide 2 into each term, the final simplified answer here is 1 plus or minus I root 29 over 6. And that, of course, did give us, as we expected, 2 imaginary solutions. On your own, I would pause the video, try number 13 and 14, and come back and check your work. With number 13, before we start, we want to rewrite it so that we have 0 on the right side. So we have to move the 5 over. And now we can go ahead. So our answers are 5 and negative 1, which are indeed 2 real solutions. And we did indeed get two real solutions when we use the quadratic formula for number 14. Okay, everyone, I hope this helps. Have a great day.